All right, guys, so going back and talking about how to graph systems of equations, since I probably should have made this one first, since this is what we talked about first, but I was so excited to get into solving that I did solving by substitution. Little booger here is gonna help teach us math today. So first thing is I could not use our note examples because those are already pre-done. They're already, okay, bye. They're already graphed for us. So cutting those would not have worked very well because I would already see the solutions and I can't cut out the solutions. It would make it impossible. So these are different examples in our notes, but same general idea. I just snipped them. So I am going to make the legend. And so this first equation is going to be blue. So we're going to start up 4. And then I have a slope of, I want to make that a little bit bigger. I have a slope of -2. So negative means I need to go down and to the right. So I'm going to go down 2 and then to the right 1, which my angle, the lines are awful. There we go. And then I go down 2 more. And then I go right 1 more. And then I could go backwards of going back to my y-intercept and doing the opposite of up to left 1 and up to left 1. And then I can make a handy dandy line. And color it blue. And my dots are not the most accurate on my computer, so I had to, my dots to my line are slightly off. So we'll just fix them real quick. It's really hard to be accurate when you're graphing a line like this on your computer with your fingers. It's not the easiest thing in the world. Okay, so then let's do the next one and make it red. So we'll do +1 because that is where my y-intercept is. Again, I'm going to make my dot a smidge bigger. So +1. And then I have a slope of -1, which means down 1, right 1, and down 1, right 1. And then we go back and we go up 1, left 1, and up 1, left 1. And then we make our handy dandy line. Let's color it red. And theoretically, we will create our line of intersection, or point of intersection. And our point of intersection is right here. Can I zoom this in? No. Which is at 3, -2. Might be able to zoom it in if I group everything and then make it bigger. Haha. So we see that we intersect in the 4th quadrant. And I'm blowing it up so you can see it a little bit easier. I wanted to make sure the entire coordinate 4 quadrants could fit on the picture, so I didn't have to move it around because that would be difficult. But yeah, I can zoom it in. So we meet right here at 3, -2. So my solution is 3, -2. All right, let's go do another problem. So we are going to start exactly the same way. I might zoom it in just a little bit. I wasn't sure how this was going to look on screen yet, so I didn't want it to be I didn't want it to be too big. So let's go ahead and do blue and red again, because why not? So we will do blue for the first line again. So that starts up 1, because I see +1, which is the y-intercept, and I need to make that size bigger. So +1. And then from there, we're down 2 again to the right 1, down 2 to the right 1. And then we go backwards and we go up 2 to the left 1, up 2 to the left 1. And we draw our line, and I'm not going to worry about trying to make the ends appropriate. Ha, it did it for me. Cool. And I think we need to extend it all the way we can. There we go. So then let's go ahead and do our red line now, where we go up 7, which is here. Oops, too small. Forgot to change dot size. And then we're up 1, right 1, up 1, right 1, and down 1, left 1, and down 1, left 1. Boom, we already intersect right there. I do want to create my line because we do need to be getting in the habit of creating an appropriate line, whether you see the cross or not. So this time we intersect at -2, 5. All right, slightly more complex of a problem, not too bad. Okay, I'm gonna blow this up. I have to sneeze. Allergies are not fun right now, by the way, because everyone who hears you sneeze thinks that like you're dying. I'm not dying. I have awesome allergies. So we're gonna start up 1. Got a slope of -4, so down 4. 1, 2, 3, 4 to the right 1. 1, 2, 3, 4 to the right 1. Angle on my my computer is not the best. So up 4, 1, 4, right, left 1, and up 4, left 1. And let's connect those dots. Let's go and do our other line now, make it red. This time we are starting down 5 because it's negative. And we need to go up 2 to the right 1. Boom, found my dot. Connect those lines, make it red. And my point of intersection is 1, -3. All right, slightly more complex than our last 2, getting our levels a little bit more increased here. We're going to start with that first equation again. So let's get out our blue marker. Starting up at 4 this time, because it's +4. And then we have a slope of -1, so down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1. Let's connect those dots. This time with our second line though, of y equals 1, that's where y is forever 1. And we know the y value goes up or down. And since it's positive, it's positive 1, which is right here. And I want y to forever and always be 1. And so therefore that has to be this horizontal line. because y always has to be one going left or right. If we saw x equals, x is up and down. And so our solution point is at 3, 1. All right, so this one is going to get a little bit more complex because if you notice, that first equation is not ready to graph. So that means I need to manipulate it in order to make it graphable. So let's rewrite it. I need the x on the other side. Currently x is positive, so we subtract it. So I have negative y equals negative 3x plus 3. And then I see that that y has that negative sign, so to undo it, I divide everything by negative 1. And if I divide everything by negative 1, all of the signs flip. So now we can go ahead and graph it, and we will graph that in blue because it's our first equation. Even though it's written below it, we manipulated it as the first equation because it came first. So I have my negative 3, and then I go up 3 to the right one, and then I go up 3 to the right one, and then I go backwards and go down 3 to the left one, and down 3 to the left one. Connect the dots. And let's go ahead and do the second one now. This one is all nice and ready to go in slope-intercept form for us. So all we got to do is dot my lines. So we start down at negative 1 because this is minus 1 and I have a slope of negative 1. Ooh, not negative 1. I can't read today. Positive 1, up 1, right 1. Up 1, right 1. Down 1, left 1, and down 1, left 1. And again, we see that we've already crossed, but let's do the appropriate thing and create that line. There she is. And our crossing point is 1, 0. Ooh. So yes, a little bit more complex because we had to rewrite the problem, but overall not terrible. I believe this is my last example. Yes, okay. So a little bit more complex, just like our last one was, because if you notice, that first equation is not written in slope-intercept form, so we have to manipulate it and rewrite it. Again, I need x on the other side, so subtract it over. So I have negative 2y equals negative x plus 8. Then divide everything by negative 2. So that gives me y equals 1/2 x minus 4. Negative x divided by negative 2 turns positive. 8 divided by negative 2 is negative 4. So let's go ahead and start graphing that guy. So start down 4 and then up 1 to the right 2. Up 1, right 2. Down 1, left 2. Down 1, left 2. Connect the dots. As best we can. And then let's go do the second equation. So that one starts up 1. Ooh, okay. And then my slope is negative 3/4, so down 3, 1, 2, 3, to the right 4. And look at that, we crossed. So we have our solution here once we finish our line of 4, negative 2. Bye, guys.